All right, back to all the laws, gas law that we have learned. Right, so Boyle's law saying this: P times B always constant. Charles's law: P over T is always constant, and Montan's law, Avogadro's law. Okay, so basically, all these are constant, right? And the combined gas law, PV over NT, also a constant. That's why we have the combined gas law right here. P1, V1 over N1, T1, and we got the combined gas law. All right. Now, since the PV over NT is a constant, so let's say I'm using the constant R. I'm moving NT to the right side or times NT on both sides. So we have an ideal gas law. So PV nRT, right? PV equal to nRT, right? The R is the universal gas law. The unit could be either one, depends on what depends on the situation, what unit that you have. Usually in chemistry, we use liter, ATM, mole, and Kelvin. So there's a unit of R. So we use 0.08206. In physics, so physics deal with a lot of joules. So then you go 8.134. But these two units are the same thing. Okay, so that's the reason why you need to write down all the units. Otherwise, you won't know which the R value are you using. Right? You need to see all this unit cancel everything out. All right, I'm gonna help you. So I'm doing this one for you. Okay, but if you want to try, go for it. Like don't let me stop you. All right, what is the volume of 1 mole of helium? So N is 1, right? At the standard temperature and pressure. What is the standard temperature and pressure? So we find volume, right? N is 1. Standard temperature and pressure, or STP, is 1 atm and 0 degrees Celsius, or 273 Kelvin. Okay, so ask for volume. All right, so we're going to move P to the other side. Get that? All right, now plug in. So N is 1 mole. Keep the unit there. You want to see the unit cancel out. R, now we have ATM. We have, but we have ATM, right? So totally we have to use the 0.08206. It's the only one that have ATM as in the unit. The temperature is 273 Kelvin. And the pressure is 1 atm. All right, let's see everything cancel out. So mole cancel out, Kelvin and Kelvin, ATM and ATM. Do the math, 22.4 liter. That's the molar volume. All right, so I mentioned before, all gases in this world, at STP, 1 mole of those gases at STP, the volume is 22.4 liter. Okay, 2 moles, 44.8, 3 moles, 7. Well, you do the math there. Right, all right. One more time. At what temperature does 1.20 moles of hydrogen gas occupy a volume of 28.1 liter at a pressure of 121 kilopascals? Okay, so we're looking for temperature. We have moles, 1.20 moles, 28.1 liter, and the pressure of 121 kilopascal. We have everything, right? Just find temperature. But one thing that you have to do though, in the ideal gas, in the combined gas law, the pressure could be anything. Volume, the unit of volume could be anything because they cancel out. But in the ideal gas law, we have to follow the unit of the constant, which is R constant, right? The pressure unit of the R constant is ATM. You have to convert this guy to an ATM. Otherwise, it won't cancel out. Right? If you don't know what I'm saying, I'm going to show you a little bit. Okay, so, but first thing, convert this guy to ATM real quick. So, we have 121 kilopascal and 101.325 kilopascal is 1 ATM. So put kilopascal at the bottom, ATM at the top. Do the math. You should get that number, ATM. Keep everything there. Don't round them off yet. Okay. All right. PV and RT. All right. So we want to solve for T. So move NR to the left side. So PV over NR. You should get that. All right. P. Let's do P is, we have new P, ATM, 1.1941, blah, 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 ATM. Volume is 28.1 liter. Okay. Mole, 1.20 mole. And R 0.08206 liter ATM mole Kelvin. This is what I'm saying. If you did not convert kilopascal to ATM, your pressure right here, we have the unit of kilopascal, right? Unit will be kilopascal. Kilopascal won't be able to cancel with ATM. You're going to stuck with both ATM and kilopascal. You can't do anything with it. Okay, so convert to ATM so you can cancel out ATM, liter and liter. Per mole Kelvin, 30 flip to the top, you get mole and Kelvin. Oh, no, hold on. Mole and mole cancel out too. I forgot to say that. All right. Per Kelvin, flip to the top, you get the Kelvin. All right. Do the math, you get that number. How many sig fixed? 3 sig fixed. Round them up. 341 Kelvin. Okay. That's how we use the ideal gas law. Very simple. All right.